So obviously, if you're not sure about when due dates are, check your study schedule because they've been there from day one. But we're getting towards the end of the subject now. So today's a very quick one, and obviously we'll give you more time to do the worksheet as well as configure, work on your assignments. And don't forget, guys, I've got other times in my classes that I've given you before. Like for example, today for this class, after a sort of a short break after this class, we've got another class from 2 to 4. Okay, so there's nothing to say that you guys can't stay in here. It's the same room and keep on working through. Okay, if you're behind in a workplace, what you do is put in overtime, and basically that overtime is those extra classes we're talking about. Okay, don't forget Thursdays we have a class at 11:30 to 1:30, but I've got a tutorial from 9 a.m. to 11. Again, what a perfect opportunity to get things done in the morning, do some theory, and do more stuff, especially if you're behind. Okay, so I've been stressing that all semester long, so we're trying to give you as much opportunity as ever to get things done. It's up to you to actually do it. You know what I mean? So I know the classes have been reduced from 3 hours to 2 hours, but really, in essence, you're getting more time, aren't you? You're getting 2 hours of theory class 2 times a week, but I've just given you 2 other times, which is basically around our classes, where you can get another 2 hours, so 4 hours again. So you're really getting 8 hours compared to the 6 hours normally from last term. Okay, so really you're getting more time, but it's up to you to actually make use of that time. So don't forget. So I don't want to harp on that too long. I'm sure the people who are doing well don't want to hear it. It's really for those people who are a little bit behind. So today we're going to look at configuring encryption and auditing. So to do with security again. So we've mentioned these things quite a bit in the past. Okay. So just to recap, let's actually have a quick discussion of what encryption is. Okay. So if I actually open up obviously I can't do this on the whiteboard, so I'll do it in this Paint. Paint's probably not even the best tool for this. I might just use OneNote. So bear with me for a second. So I'm just signing in. So if you guys have not used OneNote before, what's going on here? No. All right. So I'm not going to use OneNote today. For some reason, I am going to use OneNote, but it's not going to connect up to my thing. If you've never used OneNote before, it's one of those products from your Office package, and obviously you can get the Office 365 with Office 2016 installed on your computer for free from our subscription. But it's actually a just like as the name sounds, it's for note taking. Okay, and it's basically allows you to type words, make diagrams, and all those kind of things. So if we actually talk about encryption, okay, so hopefully everyone knows what encryption is. So if I actually type in, and I've used this example in the past in my classes, if I type in that, I'm sure everyone can just read that as my name, can't they? Easy enough. That's what we call plain text, okay, which means someone can actually read it without any troubles at all. Okay, so just imagine you were sending, or you kept your documents, or you kept your you sent your documents or traffic across the internet or on a USB stick or somewhere, and you just left it as plain text. You know that if someone picks up your USB stick, they'll put it on their computer, they'll go in, and they'll be able to read it just like I can read my name, can't I? So we can just read it as my name. And if that happens to be more important than just my name, let's say that's your whole marketing strategy for your new product line for Earthy's Confectionery, or you're going to have toffees next year, okay, and peppermint swirls, and that's your new marketing product. What if your competitor, Bob's Lollies, okay, got hold of it? They could, just gazump you, couldn't they? And that's obviously a silly example, but what if it was your username password for your email or your Wi-Fi? What if it was your account to Facebook? I'm sure a lot of people have maybe had their Facebook hacked where silly posts are posted about you. Sometimes it's by your friends, sometimes it's by someone more devious. So basically, when we actually communicate over the internet, over even on any network, or even just storing our files, there's a chance that someone could just grab it and make use of it. And if it's just written like plain text, like my name is there, they can just read it. What about this one? Okay, I know it's a little bit small, so let me make it a little bit bigger. Still not big enough, is it? Let's go 24. Okay, what about that? Could you read that? You can read it. What is it? Is it a word? Can you recognize the word? No, you can't. But as smart human beings, could you work out what that word may represent? What do you think it represents, guys? It's still Alex, isn't it? And you're probably going, what? That looks nothing like Alex. And that's the whole point of encryption. It takes something that you can read, which is plain text, and turn it into something you can't read or recognize, which is called ciphertext. Plain text to ciphertext, plain data to cipher data. And basically, you guys are smart human beings, and I've just done a really, really simple example, haven't I? What I've done is I've just replaced each character with the next character. Whoa. That's not very top secret, is it? But that's just an example of something you can do. And that method of what we did is what's called an algorithm. Okay, in this case, it's purely a replacement algorithm. And the way we replaced it is by a sort of like a movement of the characters to the next character. And if we had all the characters of your keyboard on a wheel, we've just basically cranked that wheel one spot, haven't we? The next letter. And we replaced every letter with the next letter. And that's pretty easy to work out because you guys are smart human beings. And plus, I've got that Alex right in front of you on top of it. But even with that simple little algorithm of replacing the letter with the next letter, if I actually had a whole message text without the plain text form of it, it's not as straightforward as it is for you guys to work it out, would it? Okay, unless you knew that was the trick. So the way algorithms work, the way encryption works is it takes an algorithm, which is well known. Okay, there's many different encryption algorithms in the world, but it's well known. This method is well known, meaning that people around the world all know it. Because the reason why we need people to know it is because we need to use the algorithm to encrypt it, but we also need the algorithm to decrypt it, which is the opposite of encryption, which takes a encrypted data, encrypted text, cipher data, and put it back into your plain text, plain data, so you can actually work with it. There's no point having encryption if you can't get it back. Okay, so the algorithm is well known. Everyone knows about it. So you're probably going, hey, well, if everyone knows the algorithm, then it's not very secret, is it? Well, the thing that makes it unique is the key to encryption. Okay, in this case, in this example, what I've done is actually just twisted that wheel of letters by one click. Haven't I? Actually, I'll do it this way. One click across, meaning it will replace it with the next letter. But what if I actually twisted it 264 clicks? Because there's a wheel I can keep on going, can't I? That would, how would anyone even know that I've clicked it over 254 clicks? You won't know. They won't know. Even though they have the right same algorithm, they don't know how many clicks you've actually turned the wheel in this example. So therefore, this is what's called a key. So if I know that my key is I've turned it by one click, and you know that my example is I've turned it by one click, then you can just plug in that algorithm with that click of one key and reverse it, couldn't you? So basically, by knowing the algorithm and knowing the key, you can decrypt a ciphertext or cipher data back to the plain text or plain data form. So encryption is turning something that's plain and easy to read into something that's scrambled up, or it seems scrambled up and can't be read. And it's done by using a encryption algorithm, which is well known. But what makes it unique and special and secret is the key. And you may have heard the term, it's a 256-bit encryption or 128-bit encryption or something like that. Well, that's just the length of the key. We all know that if the key was only 1 bit, it can be 0 or 1. It's pretty easy to guess, isn't it? But if you have 2 bits, it's already 0, 0 or 1, 1 or 0, 1 or 1, 0. There's already 4 states. It makes it significantly harder than the 1 bit. But if we actually made it 256 bits, that's just so many possible combinations, isn't there? So that makes it very hard to guess or brute force that key. So that's what encryption is. And obviously the benefits of encryption is that we don't lose our private data, cannot be seen or read or captured or stolen by someone else, okay? And today we're going to look at encrypting drives using BitLocker and EFS, and we're going to concentrate on EFS in our worksheets and practical and our assignments, but we need to know both, okay? And then we're going to talk about auditing, which we'll talk about a little bit later. So let's actually start by looking at what is BitLocker. So BitLocker is a full drive encryption that has the following characteristics. So let's talk about what it means by full drive encryption. So I have a hard drive. Okay, a lot of you guys have portable hard drives. Okay, you take that around. You take that all over the place. You might even go to a cafe and have a coffee. Put your bag down. I've done it myself. I'll put my bag down on the seat next to me, and I've totally left the coffee place without my bag. Luckily for me, I went straight back and got my bag. But how many times have people left their bags on the train, in a cafe, or somewhere else? And how easy would it be for someone to actually find that bag, get your portable hard drive, and even look at the contents? Let's not even say it's a portable hard drive, but let's say it's your whole laptop. So a lot of these days the devices are portable, aren't they? Your phone, your tablets, your laptops, all of those things are going places with you. Okay, if someone wanted to steal your data, it doesn't matter how much what's NTFS permissions you put on there. What they could do is if they've got your device, they can take the hard drive out of the device, put it into their computer, and automatically the administrator of their device, aren't they? And the administrator of that portable hard drive, and your NTFS becomes irrelevant in that situation. So that's physical security, isn't it? If someone's gained physical access to your machine or your hard drive, then your NTFS permissions and so forth, share permissions and all those kind of things we talked about, is meaningless. All they have to do is take the hard drive out of your computer, put it in their computer, and they've got full access. So BitLocker full drive encryption basically goes one more step. It actually, like we said, uses encryption and just scrambles up all that data that's on your hard drive. Okay, it doesn't matter if they've stolen your hard drive, your laptop, or your device, and they try to put it into their device, even though they've got administrators access to that file. When they open the file, it's just junk, just scrambled up junk, unless they've got the correct key to unlock it. Okay, and so basically the encryption, in this case BitLocker, protects you against losing devices. Okay, I'm sure there's been stories in the world where people have broken into people's house, even got their personal files and photos and whatnot, and I'm sure it's been leaked on the internet all over the place. I'm sure you heard of those things. That wouldn't be possible if their drives were encrypted. Okay, that wouldn't be possible if their drives were encrypted. So encryption is everywhere, whether that be communicating over the internet, chatting with WhatsApp, for example. All those things are encrypted. And I'm sure you've heard those stories where FBI agents were trying to get the contents of a mobile iPhone, and Apple wouldn't give them the method for decrypting it. I'm sure that made news last year sometime. So basically, BitLocker is a full drive encryption that has the following characteristics. It can be used to encrypt an entire hard drive or only parts of the hard drive. So you can choose. So if you if you encrypt the whole hard drive, it means that everything on the hard drive must be decrypted in order to use it. Okay, that can be problematic because don't forget, every time you encrypt something, you are using memory and CPU power to scramble it up. Every time you decrypt it, you're using processor and memory again to decrypt it. So what if I actually encrypted my whole drive and that included the Windows operating system on there? Okay, it's not really a big deal if someone knows my Windows operating system DLL files or something like that. It's not like it's highly private or secret. It's probably the same as every other Windows installation of the same operating system. So why encrypt that? If I actually encrypt that, I'm actually making more work for my computer every time it boots up the computer, aren't I? Okay. We can also combine it with EFS, and we'll talk a little bit more about that later. That's encrypted file system, and we can choose to encrypt, again, part of the file system, a folder, or the whole drive. It can be used to protect the integrity of the Windows boot process, and some features of BitLocker are only usable with TPM, when TPM is available on the computer. That's a trusted platform module. Okay, this means that actually it's part of the hardware. Okay, this TPM or trusted platform module is part of the hardware. It's not like a piece of software. It's not an app you install. It's actually a piece of hardware that's on your motherboard. So therefore, when you actually combine that with BitLocker, before someone can even turn on your computer and actually boot to it, you have to enter some sort of key. Okay, so if someone picks up your computer again, they can't even boot up their operating system without entering some sort of credentials. So how BitLocker works? So advanced encryption standard. So it uses the AES. Okay, you might have heard the AES associated with other things like Wi-Fi. Okay, it uses a 128-bit or 256 encryption key. We spoke about how the longer the key, the more combinations there are, so the harder it is to crack. It can be used in an automated deployment with Windows PowerShell for computers which are already in production. So if you've got client computers already in your production network, we can use actually PowerShell to deploy BitLocker onto these computers. New operating system deployments can use BitLocker before the operating system files are written to the volume. So we can actually even lock it before we install the operating system. Okay, BitLocker encrypts the whole drive. It only basically, if it's the whole drive is 60 gigs, let's say that drive is, there's two options. There's only use space is encrypted, which is the fastest. Just like it's a bit like our VMware, where we actually only allocate disk space. Do not allocate disk space straight away. So it's only how much we use. So in this option, we only encrypt whatever data we actually use. The other part, which is empty, not encrypted. But then we've got the other one, which is entire hard drive is encrypted, and this is obviously the most secure for an existing computer. Okay. Some requirements. So obviously, if you want BitLocker, you need to have a sort of newish operating system. So I'm really doubting anyone has an older operating system than Windows Vista. Okay. I'll be surprised if anyone even has Windows Vista. Or Windows XP. I'll be surprised if anyone has anything older than Windows 7 these days. Okay, in most situations. I'm not going to say every situation, but I'll be surprised if I saw one. Yes, Andrew. Yeah, it's not the home version. Okay, for the home version, there's the BitLocker to go, which allows us to encrypt USB sticks and portable hard drives. Yes. So also Windows XP supports the ability to read and copy data from a portable hard drive encrypted with BitLocker to go. So the BitLocker to go is similar to BitLocker, but it's really for the portable hard drives and USB sticks. The TPM or the Trusted Platform Module offers additional features such as system integrity verification and multi-factor authentication. So obviously, when we're talking about system integrity verification, it verifies who you are before you can turn on the computer, and also make sure that the bootable files is actually the right bootable files. Think about it. How easy it is today that I can actually create a boot disk on my USB stick, insert it into this computer, which is part of the TFSA network, and boot up from the USB stick instead of the actual hard drive. Whoa, now suddenly I'm the administrator of this computer instead of being just a user. Now I can have potentially lots and lots of different tools on this USB stick, which is part of this operating system I've booted from, to actually do things. So what this TPM actually checks also as part of it is that you are actually booting this computer up with from the right place, and it has it's the right system, if you like. Okay, so people just can't come around with their portable USB sticks and boot up to wherever the operating system they want with whatever tools they have. So again, let me reiterate that TPM is actually a hardware component that you can get on some hardware now. And obviously, this part of it only works if you've got that hardware component. It's a multi-factor authentication as well. So besides knowing your username and password to get onto this computer, you have to know something else. More than one thing you're authenticating against. So when we're configuring BitLocker, we can enable the TPM on a computer. This is optional. Obviously, if you want to use the TPM like we just talked about, you should. And then we add the BitLocker drive encryption feature on the server. Okay, so for the server grade machines, this is probably very important. So we've been talking about client machines, and it works on client and both servers. But obviously, if someone's got physical access to your server, oh my God, that's really just worst case scenario almost. Okay, so we can actually obviously put this onto our servers as well. We can configure group policies or local group policies for BitLocker settings, which require the computer which is required if the computer does not have the TPM chip. When we need to turn on the BitLocker on the desired volumes. Like I said, maybe not all volumes need to be encrypted. Maybe the C drive, which is where the operating system and program files are, we don't really care. Maybe the D drive, which is all our documents and our personal private information is stored. Maybe we do want to encrypt that. Okay? Because don't forget, we're in those situations where we've left our phone, left our device, someone's just stolen our devices or taken it. We're not really thinking of getting those devices back. Okay, we're not thinking of actually getting that data that's stored on the device back to our possession. We're just making sure that someone else who has that device can't look at that information and make any sense of it. Okay, so in those situations, you'll probably not likely get those devices back. So using group policies to manage BitLocker. So group policy offers about 40 different settings to manage and configure BitLocker. So you'll be thankful for that, because that means we don't have to manually configure BitLocker on each of the computers. Okay, we could just make it as group policy, and we all seen how group policies work. And when they log in, turn on, and log in and turn on into the network or domain, they'll get these BitLocker settings pushed to them. Some of these common settings are choose the drive encryption method and cipher strength. Okay, so basically, how strong is your encryption? Like we said, 128-bit to 56-bit. Deny write access to fixed data volumes, removable drives not protected by BitLocker. Okay, so basically, if we insert a USB stick that doesn't have BitLocker, what this setting will do is it only gives us a read-only copy from that drive. Okay. In fact, there was one stage where the TFSA here, we're gonna install BitLocker on all of these computers, and you can imagine you guys have portable hard drives. That's obviously doesn't have BitLocker on there, does it? But if you plug it into our computers and use it, they'll lock it with BitLocker. And if you don't want to lock it with BitLocker, they'll make it read-only, which is what this is saying. But we said to them, that's a little bit too much for our students. Maybe for the hairdressing students that don't really need much space and stuff like that, it's not a big deal. But for our students, can we really be, what if we encrypt someone's hard drive and they can't access their information? Wouldn't it be terrible? Okay, and if they only had read-only copy of what's on their hard drive, what about when you guys need to run your virtual machines from your portable hard drives? Okay, well, if you were going to give us a portable hard drive for us to mark your work on your portable hard drives, if we plug it into our computer and it locked it for you guys, it wouldn't be a good thing, would it? And if it's read-only copy, then we'll have to transfer it from your drive to our drive before we can even run it. So that was proposed at one stage, but we convinced them not to do it for IT studies. Okay. Okay, we can also configure group policies to use password for fixed data drives, removable data drives. We also can configure require additional authentication at startup. That's where we're talking about with the TPM. And we also allowed for a network unlock at startup. So basically, if the person who's sitting in front of that computer doesn't know that information, could be you guys as students, but it could be unlocked over the network by administrator so that your computer can be booted up successfully. So the next thing is EFS, encrypted file system. Okay, so what is EFS? EFS, or encrypted file system, can encrypt files that are stored on an NTFS formatted drive or partition. EFS encryption acts as an additional layer of security, and EFS can be used with no pre-configuration, so we can actually just turn on EFS or not. Okay, it's EFS is fairly simple. Let me just quickly show you what I'm talking about with EFS. So this is the really easy, simple encryption that you can turn on anytime you want. Okay, so the key thing is it has to be like a NTFS partition. Let's look at my D drive, or it's not even formatted. So let's quickly format that as NTFS. All right. Mike. All right. Let's quickly format that, and that's a quick format, so it's ready to go. Now it's NTFS. If we actually look at it, the file system is NTFS, and obviously we all know that the NTFS is the file system that Windows defaults to these days, and obviously we should know that there's a new one called REFS. But if we actually create a new folder, and we call this top secret, and basically to turn on EFS, we can turn it on this folder. So we can go to the properties, we can go to advanced, and we can actually select encrypt the contents of this to secure the data. And it's as easy as that. Let me just quickly check that it's actually done that. Yeah. Now we can create new files. Let's bitmap, new text document, and even other folders. And because we've actually encrypted the contents of this folder, all those files and documents that we just created are actually encrypted. Okay, that's as simple as that. And obviously, how do we know it's encrypted? How do we know? The ultimate test is actually to take that drive and put it somewhere else. Okay, so obviously we're the person who encrypted. So when we actually go in, it's going to be perfectly normal, easy to read because we've encrypted it, and by default we can access it. Okay, and next time we log in, it's the same thing. So the easiest way to test that, and that's what we'll do in the worksheet, is we'll actually take a volume from one virtual machine and put it in another virtual machine. It's just like someone got your server, stole your server. They can't log into your server as administrator because they're not the administrator. But you know what they can do? They can actually take the hard drive out of your server, put it into their computer, and they can log on to their computer because they are the administrator. And like I said, normally if that happens, they become administrator and they can access your hard drive, no problems. Read the data, no problems, because it's just the files on an NTFS partition, isn't it? But with encrypted file system, because they're encrypted and because this is a totally different user, and remember when we talked about the SID of a user, SID of a computer, SID of that, it uses that and it knows this is a different user, and this user does not possess the key, and therefore they can't read the files. Okay, and when you do that in your worksheet, it will become a little bit more obvious. So how does EFS actually work? We use symmetric encryption is used to protect the data. We can also use public key encryption is used to protect the symmetric key. Okay, so basically there's a plain text file. We use the symmetric key to actually encrypt it, and this is encrypted. Then we actually take the symmetric key with our public key infrastructure and actually encrypt that key, and then combine it, and it's encrypted with encrypted file. So that's great. That's how it works. Okay, so it basically takes a plain text file, turns it into an encrypted file. But the question is, hey, what about when you decrypt it? So this is an encrypted file, and basically we can actually use the symmetric key or the private key to actually decrypt the symmetric key and get the file. And it's a plain text file again. Okay, so we're locking it, then we by encrypting, and we unlocking it by decryption. But what if you're part of a domain and one of your users encrypted the files? Okay, and they got sacked because of other reasons, but they've encrypted the files. Obviously, because they are actually a member of the domain. Okay, we're saying that's the first proviso. The member of the domain, we can actually recover the encrypted file system, encrypted files, if you have a backup the user certificate and you configure a recovery agent. You must back up the recovery key to secure against a system failure, and we need to make the recovery key portable. Okay, so as a domain administrator, and these users are part of the domain, we can do this and unlock the files they've encrypted with their account. Okay, obviously if we're talking about standalone computers, that's a different story. Okay, so unless you did this yourself, the person did this yourself, they wouldn't be able to recover it. And obviously you don't want to be in that situation where you have important files that you can't recover. You're basically just got yourself with some sort of crypto locker type attack, haven't you? So that's a potential problem. So which one do we use, an encrypted file system or BitLocker? So if it's a shared computer where lots of people are using it, but we don't want someone else that's using this computer from looking at our files, we can use EFS. Okay, we use EFS, offers folder encryption, and ensures that users that on a shared computer cannot view other people's data. Okay, if it's a portable computer like a laptop device or a portable hard drive, we can use BitLocker, protects the entire hard drive, which ensures the data is protected no matter where it is stored and where it's stored on the hard drive. In a high security environment, let's say we're working for British Aerospace and we're developing the next defense system. And obviously, the fact is, if that bits of information got out, that could be highly dangerous and stuff. So in a high security environment, we might combine EFS and BitLocker and provide more data protection than just themselves on its own. Okay. To be honest, if I was working in that highly encrypted area, maybe I wouldn't even allow people to plug in portable drives or take computers which got information like that away from the workplace. So a lot of people, don't realize this, but physical security is probably the easiest thing you can implement with the highest effect. Okay, so for example, these computers are plugged into a network point. Okay, if someone could open the door and come in, they could just plug in their laptop to that network point. They're part of the TFSA network, and they can just do it. They can run whatever programs they have on that computer. You know what? If I just actually place a lock on there and I don't give people access, that person with that laptop just stopped him from being able to access the network. Okay, I'm not talking about TAFE because TAFE is designed by nature to allow students to come in and visitors to come in to use their own devices. If I'm talking about your highly secured environment like a British aerospace somewhere, okay? If we actually don't let people bring their own devices to work, they can't bring viruses, they can't bring pre-configured software, pre-configured tools on their systems, okay? If we don't let them take devices or drives or stuff away from the workplace, it's a lot harder to store blueprints on a flash drive and take it and give it to someone physically, can't it? So therefore, yeah, a lot of places like that in that highly secured environment means that you only can do work at work. Okay, you cannot bring in devices, you cannot take out devices, and in fact, they have, you know, if in a highly secure environment, another physical security could be just a metal detector. Okay, X-ray machine. They're all physical security. You put your bags through an X-ray machine before you can go to work. You put your bag in a X-ray machine after work, and you shouldn't be carrying anything more than, yeah, your lunch maybe, or even that. Maybe they even supply a canteen for you, so you don't need to bring anything. So obviously, when we're talking about security, when we're talking about a specific technology like these things, don't think that that is the be all and end all for everything. Okay, like I said previously, and if hopefully you guys remember, what I say security is like. Does anyone remember? What is security like? I compared it with a cartoon character. No? No one? Shrek, that's right. Why is that? Because Shrek is like an onion. It's got layers, okay? So basically, not one thing in security is going to protect you against everything. But hopefully you've got those many layers: firewall, physical protection, encryption, you know, user auditing, NTFS permissions, encryption, you know, like a Wi-Fi security. All of those things now combine to stop various little things. Okay, so don't forget, just because we're talking about this one piece of technology, that's not it. That's not the answer for everything. All right, next thing we're talking about is auditing. Remember we spoke about auditing before, is like how can we, in fact, know what people are doing? Okay, just because, like I said, I gave you an example before, just because you can do something doesn't mean you always should be doing that thing. I'll give you, last time I gave you an example which is a little bit controversial. This time I'll give you another example. I knew someone who worked in a tax office. He was a new employee, and he's got inducted, and he's got given access to the taxation system. And his job was to answer the phone and look up your details in the system and give you answers to questions that you might be asking. So, you know, that's great. He's got a lot of power. Yeah, you know what the comics say: with great power comes great responsibility. So, you know what he did? He thought, oh, wouldn't it be funny if I actually looked up my friend's details? Okay, my friend, he's driving a new Porsche or a new car. Let's find out how much is he making. What is he claiming? And guess what? He got busted. Okay, he got busted because they were doing auditing. Because they're only supposed to look up people's details that actually they get a direct question from. That's the way they should be accessing the system. Do you agree with me? Would you like it if your friend was looking up your details on their systems about your personal income and stuff like that, what you claim for, what you stuff? Of course, no one likes that. And that's one of the, you know, major foundations in Australian society, is that you're entitled to your privacy. Okay, so he was actually busted, caught, because of this auditing stuff. His auditing saw that he accessed these files, and when it was compared to the logs of his calls, it didn't match up. Okay, so it didn't match up that these guys were called, but he's looking at people's details that weren't on this list. So guess what? I got a phone call to say, hey, this person's, did you ask this person to look up your details? Well, I didn't know anything about it, but, you know, it's my friend. I don't want him to get in trouble. So what I said, yeah, I asked him just the other day just to look up a couple of things for me. And as a result, he didn't get any serious trouble, but he did get sacked from his job. Okay, so basically, they would not be able to catch him if there was no such thing as auditing. Okay, and basically auditing is your evidence trail. Auditing is your logs of what's happening, who's accessing what, especially when it's a highly confidential area. Let's say it's your secret recipes of Lou's Lollies. Okay, this is where we keep the recipes, and only the master chefs on the Lou's Lollies company can access it. But just because of that doesn't mean that other people don't have access. They might have the NTFS permissions to look at it, like the system administrator, but doesn't mean they should. So what we could do is actually implement auditing, and we can audit events by activity categories such as access to the NTFS REFS file systems or folders. We can look at account or object access in the Active Directory. So did someone reset someone's password? Whoa, if I reset your password as administrator, maybe I'm doing it as part of my job, which is fine because you forgot your password. But maybe I'm resetting your password so I can actually know your password and log in with your account to access your files, or even the files you're encrypted with, because now I know your password, right? So basically, auditing that means that, hey, if someone complains that someone's been snooping in his account for some reason, we can go back to logs and see what's happened. And that allows us to actually work out who it is. What about logon attempts? Okay, we can audit that. So who's been trying to log on to the domain controller computer? Oh, well, normal people shouldn't be trying to log on to the domain controller, should they? I mean, they should be logging on to a computer, which then sends it to the domain controller, but they shouldn't be trying to log on to the domain controller. So maybe we can, that's just an example, of course. Maybe we can work out who's been successfully and unsuccessfully trying to log on to the domain controller. It might tell us a story. Okay, the unsuccessful logons might say, hey, Peter Jones is trying a few times to log on to the domain controller. Well, maybe I should have a chat with Peter Jones. Why? He's a regular user. Is it just a mistake? But maybe the 20 times he's tried to log on, it doesn't sound like a mistake, does it? Or even if it's someone successfully logged on. Okay, so on last Friday, 5 p.m., we had a security problem. Well, who was logged on at that point in time? And again, this audit can tell us. Okay. We can also audit assignment of users, assignment of use of user rights. So remember how we can delegate permissions in Active Directory, in file system, and all those kind of things we've been talking about. We can audit that, who's been delegating rights and when they were delegating rights. Did someone use the administrator account, which is a administrator account, to delegate their own personal account more permissions than they needed? Okay, for example. By default, domain controller audits successful events for most categories. The goal is to align your audit policies with your corporate security policies. Over auditing is a problem as well. If you end up trying to audit everything, every little part of your file system and every event, then it can just create a huge log. And the problem with having too much information is that it makes the really relevant information very hard to find. So there's a possibility of auditing. So maybe don't audit everything. Audit only the specific areas of the file system, the specific systems like Active Directory, stuff like that. And obviously that will give you more relevant information. There's also a problem of under auditing where you just took it too lightly and you didn't audit anything. You just stuck with default auditing. And obviously at that point in time when they want to find out information, who was that person who logged on to that computer on Fridays, the 13th of October, and you don't know. Well, that computer was used to do something naughty. Then you don't know. Okay, so here's an example of auditing. So this is on a folder, for example. Let me just quickly show you that. But the auditing is more than just auditing on the folder. You have to actually turn on the auditing via group policies as well. But on this folder, so obviously we're auditing folder or file access now. Okay, so it's not those other things that we just spoke about. So we go to properties. So this is a top secret folder. We can go to security, we go to advanced, and then we got an auditing tab. Okay, right now nothing is being audited besides what's there by default. But what we can do is we can add and we can select a principal. Okay, so principal is someone, a group or user. Okay, if we want to make it really specific, we can say this group of people, or we can be general and find authenticated users, or domain users. Okay, that's pretty much everyone with a domain account. Okay, so if we actually, so this is general, so I don't know who's going to actually access this file. Let's say anyone can access it, but if it's restricted, if this is a top secret area, maybe only a specific group can access it. But in this case, I'm choosing everyone, and I can audit fails or success. So maybe I'll do all, so fails and successful, because fails tells you one story, success can give you other information. And now what does it apply to? It applies to this folder, its subfolders, and the files. So everything inside this folder. And here are some default, it's just like your permissions. Who's actually, what things are they executing on these files? What permission level? Or we can go to advanced, and we can actually look at, if we actually choose this full control, it basically does everything. But if we just want to see who's actually looking at this folder or going into this folder, we could actually just do traverse folder execute files. Who's going into the folder and who's executing files. Log that. Or list folder contents, who's actually just snooping around. So these other ones are reading the permissions, changing the permissions, taking ownership, creating data. We can log all those kind of things. Okay. So that's how you configure the logging on the file system, but you have to implement logging with group policies first, and we'll do that in our worksheet today. So auditing settings for a file or folder are specified by modifying the SACL, the access control list, security access control list. Full control will record all associated events. Recording audit events will not occur until the audit policy is enabled first. Okay, like I was saying. When we enable the auditing policy, we enable the audit policy by configuring the audit policy settings in group policy objects. Enable the appropriate settings in GPO. Apply the GPO to the Active Directory domain services container where you want to, where your servers are located. And these are some of the, this is an example of the audit logs. Okay. So obviously you can see this in the event viewer. Okay, so let me just see if we got any logs in there. So if you remember, we can actually look at all the Windows logs in the event viewer. And when we set up this auditing, we are actually looking at the security logs. Okay, so right now by default, we are auditing logons. But once you actually do what we have to do in the worksheet, you'll see that we will see other security logs in here as well. All right. So in Server 2012 and 16 and 8, it provides an additional set of advanced audit policies in here. Okay. So again, these are group policy objects that we need to change to implement the logging and auditing. So that's the end of this PowerPoint, and what I want you guys to do now is actually to work on the, I'll leave it up to you, okay? Because there's no point doing this part of the worksheet until you need it in your assignment, really. And at this stage, your assignment is becoming your priority now, okay? If you're ahead of where you are and you're good, and I've given you that feedback that you're good and you're going great, then yeah, go forth and do this stuff. But if you're a little bit behind now, rather you work on the stuff that you meant to have done by now. So maybe determine that for yourselves. I'm not saying don't do this ever. I'm just saying maybe right now, do what you need to do to make sure you're up to the stage where you need to get up to. Really, that's with VPN finished by this stage and with possibly DFS set up by the end of this week. Okay.